Kepler's three laws of planetary motion revolutionized the way that we think about the universe. The first law of planetary motion says that planets orbit the Sun in ellipses with the Sun at one focus. The plural of focus is foci. And one way to define an ellipse is that it's an infinite set of points such that the distance from that one point to one of the foci and then on to the other foci and back to the original point is constant. In other words, you can make a triangle between any of the infinite number of points and the two foci that are fixed points in space and show the outline of the ellipse. This is a practical illustration of Kepler's first law of planetary motion. And how I've set it up is that there's a steel board with a piece of paper on top of it. And then there's a film can, and inside the film can, this is a 35mm film can, there's a strong magnet. So the magnet is attracted to the board behind the paper, and you can move the film can around anywhere. To show the second focus, you just take a second film can and place it on the board. So now we have two film cans and then a piece of string that you can run around the two film cans. And when I place my finger at some position, we form a triangle between one focus, the other focus, and my finger. And so the definition of the ellipse in this manner is that the distance from this finger to this focus, and back to this finger is a constant value regardless of the position of my finger. So to show the shape of an ellipse, you can take a pen and put the pen in place of your finger and trace around the two film cans on the piece of paper, and it forms a nice ellipse. And a lot of students will say, oh, that's just a circle. You made simply a circle. But in fact, it's not a simple circle. One thing you can do is remove the film cans then and measure the distance from here to here along the major axis and find that it's a greater distance than the distance from here to here along the minor axis. So it looks pretty close to a circle, but it definitely isn't. And one way to illustrate that it's not a circle is to increase the distance between the film cans. So in one case, this would be the example of a planet that actually has a fairly eccentric orbit. And this here we're going to fix as the position of our Sun, or any star in the center of the system. One thing to always illustrate to students is that the Sun is the position of one of the foci of the ellipse of any object in orbit, but the second focus is a point in space. There isn't necessarily anything at this point, it's just a mathematical definition that helps you complete the ellipse. So there could be something there, but there doesn't have to be something there, and the object that's there actually will affect the orbit. This is an example of an orbit that's actually fairly elliptical of an object around the Sun. Maybe an asteroid. There are no planets in our solar system that have that eccentric of an orbit. But if we move this object further out, move the second focus further out, and then run the string around it again, we can illustrate the orbit of a comet. So comets take fairly eccentric orbits where the distance along the major axis is much greater than the distance along the minor axis. And this actually leads to the second law of motion, which deals with the equal area, equal time law. If we bring it much closer, this shows a better example of objects that are actually in orbit around our Sun as planets, where the eccentricity isn't very great. The eccentricity is the degree to which the ellipse is more oval or flattened in a way than it is to a circle. And you might even have your students say, oh, this is a perfect circle, but in fact it's not, because students should know that a circle is an infinite set of points equidistant from another point. So here, if we use the pen and go around once again, this is a perfect circle. This is a great classroom demonstration for Kepler's first law. Rather than using the magnet in the film can on a steel board, if you have a whiteboard that's magnetized, you can apply the film can directly to the magnetic whiteboard or to a chalkboard. And then rather than using a marker on paper, you can draw directly on the board with chalk in the case of a chalkboard or white board marker in the case of a whiteboard. Rather than doing a whole class demonstration, this can also be a discovery learning activity or a lab activity for students looking to understand more about ellipses, either in a physics class or an astronomy class, or even in a trig class when studying conic sections. You could have a piece of cork board into which you put a piece of paper on top and then have push pins The push pins can act in place of the film cans and magnets as the foci, and then use a piece of string, and students can cut their own piece of string and change the length of the string and change the distances between the foci to get different kinds of ellipses.